Done. This is TCP header. Let me copy this TCP header from here. Okay, guys, what is the size of source port?
16 bits.
Yes, this one is 16 bits. Source port is 16 bits. Destination port also 16 bits. Sequence number is 32
32
bits.
bits.
Acknowledgement is also 32 bits. Header length is, what is the size of header length? 4 bits. 4 bits. Now here question is, what is that size of TCP header?
20 bytes.
20 byte to 60 byte. By default it is 16 to 20 bytes. By default it is 20 bytes. Very good. Okay, now size of TCP header can be up to 60 bytes. So let's say, okay, first question is, can a TCP header size be 22 bytes? Can TCP header
Yes.
size be
Yes.
22 bytes? Yes. Brother, how you can represent 22 bytes by using 4 bits? Is it possible? By using 4 bits, minimum value that you can represent is all bits 0. Decimal value will be 0 and maximum value will be all 1. That will be what? 1. Oh, sorry, that will be 15. Yes or no?
Yes.
So how you can represent 22 bytes by using 4 bits? That means you guys have not, checked your book. Yes or no? Yes. Actually, header length is multiplier. Let me write here. Header length. Header length is definitely 4 bits information, but it is an multiplier of 32. Just wait guys, keyboard is not working. Let me change the cell. Yes, Rohit. Is it clear, brother? How we are using header length in TCP header? And size of TCP header cannot be 22 bytes. Header length should be, means size of TCP header should be divisible with 32 in bits. Okay. Okay guys. So answer of this question is, can a TCP header length can be 22 byte or not? So answer is no, because you will multiply 22 by 8, so you will get value in bits. So what value you will get? 176. You will divide it with 32. So what value you will get over here? You will get 5 point something. 5.5. Okay. So 22 byte is actually not divisible with 32 in bits. Right? That's why size of TCP header cannot be 22 bytes. Value should be divisible with 32 in bits. Done. Okay, now one more question from the same topic. TCP header length can be 24 byte. Yes, tell me guys. Can be 24 bytes. Please calculate it. First you will convert it into bits. Then you will divide it with 32 to check that number is divisible with 32 or not. Because you know header length is multiplier of 32.
Yes, sir.
Yes. Then what will be the header length value in
6.
binary?
6.
6. So you will
Sorry.
0 1 1 0.
Yeah.
This will be the header length, yes or no?
Yes.
And if the size of TCP header is 22 bytes, let's say size of TCP header is 22 bytes, so we will add some more value over here by using padding. Okay, after that, flag. How many flag we have?
8 flag.
8 flag we have.
Yes, sir.
Can you tell me the name of each flag?
Sync, egg, reset, finish, push, urgent. I know only 6, sir.
6.
Uh,
Okay, what is the use of syn?
to synchronize
Yes, to
with the server.
synchronize. This flag is used to, we can say, initialize the negotiation, or it is used to perform synchronization between sender and receiver. Next flag is acknowledgement. Yes, what is the use of this flag, guys?
It is used to get the acknowledgement
Yes,
for the
this flag is used to indicate the successful delivery of segment. If acknowledgement is not received, then sender will perform retransmission. Yes or no? Yesterday we had discussed this also. After that,
Yes,
the
sir.
important flag is push flag. Push flag. What is the use of push flag? Guys, you know TCP always try to send data equal to the maximum segment size equal to MSS. By default, MSS is what on Cisco devices? Maximum segment size is? Hello?
Maximum size
14.
of the data that maximum size of the segment data that can a data carry.
Yes, and what is the size of maximum segment size?
1460.
1460. So actually TCP always try to complete 1460 data. Let's say application layer is delivering some data to transport layer. So transport layer will try to collect the data first. When it will receive 1460 data, then it will send. Let's say application layer is sending one telnet data, right? And size of telnet data is, let's say, 100 byte only. 100 byte. So transport layer actually will wait for the next data, that until and unless it will not complete the 1460 data, the complete MSS, it will not send. But through push flag, what we can do, we can push the data. We can tell to transport layer to send 100 byte of data. Push flag. After that, next flag is guys,
Urgent, sir.
Urgent flag. What is the use of urgent flag?
Command the server to urgently deliver the data. Something.
Anything else? Hello. Yes, Nirav.
So I guess it is related to quality of service, maybe.
Immediately need the data, something like that.
Okay. And Nirav, according to you, what is the definition of urgent flag? Sorry, push flag.
Push flag.
Yes.
Like not very much clear, but like it will forcefully send the data before it gets to 1460 bytes.
Yes, exactly. Or you can say, you know, this flag is used to avoid data buffering at transport layer. Buffering.
Yeah, overwrite.
Yes.
Buffering overwrite it will provide.
And you know, this flag, push flag, is mostly used in case of telnet, SSH, like this type of services. Because quickly we need to send the telnet data from one device to another device, from source to destination. So that time we are using this push flag. And urgent flag is used to mark the data. If you
So
want
that is
to
basically QoS, no, sir?
yes,
Marking.
exactly, or to send the data urgently. By default, devices send data on the perform transmission on the basis of first come first out. Yes or no? Out of this, if you want to mark some you know, some data, then we can use this flag, urgent flag. It was designed to mark the data which need to process urgently, we can say. And then next flag is reset flag. Reset flag. So reset flag uses, yesterday also we had discussed the reset flag. One use of reset flag.
When server is down or not able to handle any more other requests,
Not
then
server,
it's
that service or
service.
port number. A machine can use reset flag for multiple reasons. The receiving machine does not support the requested service or port number. That can be one reason. This flag is also used to stop transmission. Let's say a server, you are sending some request to a server and server don't want to, you know, accept your request. So the server can send you the reset flag that please don't send any more traffic towards this service. And after that, fin. So fin flag is, fin means finish. Fin flag, what is the use of this flag?
To tear down the
connection.
session.
Yes, to terminate the connection or to close the connection. After that, in TCP header, we had no discuss, I think. There is not more important. Window size. Window size also we had discussed. It is used to reduce the number of acknowledgement. If receiver machine or destination machine will send one acknowledgement after every segment, then communication process will be very slow. So that's why we come up with window technique. So while three-way handshake, both machines will negotiate their buffer memory. On the basis of that, they will elect one window size. And sender machine will send message equivalent to the window size. And after that, machine will expect acknowledgement. Yes or no?
Sir, for this window size, say for example, A end and B end. Okay, so they are transmitting and acknowledging the data. And say for example, B has sent the window size as 500 bytes.
Okay.
So say for example, currently A is only sending the data to B, and
Okay.
the window size they have negotiated is around 500 bytes, sir.
Okay.
So for example, if B's buffer memory gets empty, okay, so
It will
in between the
increase
session,
the window
yeah.
size.
So in between only it will send this window size, no, sir?
Yes, definitely.
Okay, okay, okay. So in each acknowledgement or sequence number or acknowledgement number, like in each segment, they will be sending the window size, correct, sir?
Definitely.
Only. Okay, okay.
Okay, after that there is not any important for source port, destination port, sequence number, acknowledgement number. These things very basic things, and we have discussed. Now I am going to start IP header. Okay, IP header is also very important topic. First of all, I am going to copy IP header from here. This is UDP header. In UDP header, you can see there is source port, destination port, header length, and checksum only after that data. And this is your IP header, right? In IP header, first of all, we have version. In IPv4 header, first of all, we have version. So how many version we have?
2.
We have two
I-
version. Yes, of
4 and
IPv4.
6.
4 and 6. IP version. Version 4. If IP version, we are using IP version 4, then value will be what?
0x800.
This one will be the value in version, in binary.
Yes.
Because we have 4 bits for version. Yes or no?
Yes.
Sir.
That is type code. That will be the type code in the Ethernet header. Nirav.
Oh, yes, 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 yes. In either Ethernet type, yes.
Yes. I am talking
Okay.
about what will be the value inside the version
Yeah,
field.
okay.
Okay. And if we are using IPv6, then value will be
0110.
0110. Done. So in version field, value can be 0100. Now we are talking about the IPv4. So here value will be 0100. After that, again we have header length. So size of header length is again 4 bits. 4 bits. And it is multiplier again, header length. Because default size of header length, default size of IP header is what?
20 bytes.
20 bytes. And it can be up to,
60.
yes, 20 bytes, and it can be up to 60 byte. Done. Now the sender machine will divide the total bits with 32, like TCP. Because here also now, how we can represent 60 bytes or 20 bytes by using 4 bits? It is not possible. Yes or no? By using 4 bits, can we represent 60 byte? No.
No, sir.
No.
So actually it is multiplier of 32 again. So if my header size is 20 bytes, then what will be the value in header length? 20 multiplied by 8, it will be 160, and 160 divided by 32, what value you will get?
5.
5. And in binary, what is the binary of 5?
0 1 0 1 0.
Wait. Binary of 5 is 4. This one, right? So this will be the value inside the IP header. 0101. After that, TOS field. So this field is for
Type
quality
of
of
service.
service. Yes,
Quality of service.
quality of service. Very important field in IP header. When you will learn the quality of service, that time you will learn, much more about this field. But now, see, the size of TOS field is 8 bits. It is an 8 bits value. It is used to perform again marking with the data. On the basis of TOS marking, a specific data can be, or we can say, we can put priority on a data by using this field, by using this 8 bits. Quality of service means how router will treat the data, or how a packet can be treated by a router, switch and firewall. As I already told you that by default router perform forwarding on the basis of first in first out, first in first out. But with the help of TOS field, with the help of this 8 bits value, what we can do, we can mark on data, so that we can actually change the behavior, that how router should treat with the data. Okay, so this is 8 bits, and out of these 8 bits, it. First 6 bit is 1, 2, 3, 4, 5, 6, 7, 8. Okay. See, first 8 bits means till here. This is nothing but DSCP. DSCP stands for differentiated service code point. Done. And last 2 bits is your ECN. ECN stands for, can anyone tell me what is ECN stand for? What ECN stand for? Explicit congestion notification. I will show you practically as well this thing, don't worry. So as I told you that by default router perform, by default, yes.
Can you tell me please what the DSCP means one more time? It's a direct service, what?
Differentiated service code point. This is a part of quality of service, brother, by the way. Okay, because you guys are a student of CCNP, that's why I am explaining these things over here. But in the routing and switching, this is not a part of routing and switching, this field, actually this particular field inside the IP header. Okay, don't worry, I will show you this thing practically as well. What I am saying, that by default 6 bits is, not by default, 6 bits is reserved for DSCP, and last 2 bits is reserved for ECN, because we have total 8 bits for TOS, for quality of service inside the IP header. IP protocol provide multiple services. Okay, brother, like logical addressing, it is providing source IP, destination IP, means IP protocol providing addressing, logical addressing services. It provide quality of service as well. It provide fragmentation as well. It provide loop avoidance, TTL as well. So these are what function of IPv4, IP protocol. Okay, So just I am discussing one function of IP protocol, that is quality of service. Just I am giving you one overview. So I am saying that by default, router perform first in first out, means it will receive the first packet and it will out that packet first. But with the help of quality of service, what we can do, we can prioritize the data, we can prioritize the traffic, we can put the priority on data, that this data is important. Here router, please process this data first. Getting my point? Getting my point, guys? So with the help of this field, toss field, what we can do, we can prioritize the data. That's it. After that, we have this field total length. Total length is data, length of data plus header. Why we have total length field also and header length also? Header length will identify the length of header and total length will identify the length of data plus header. Total size of data at network layer. So it is 16 bits value. So range will be 0 to 65535. It indicates that how much data can be encapsulated along with IP header. How much data can be encapsulated with IP header. Because let's say total length is what? Header length is, let's say header length equals 20 and total length equals 500 byte. So can you tell me how much data is encapsulated with IP header? Yes, easily we can identify. Easily we can identify that how much data is encapsulated with IP. It means IP can encapsulate, up to, okay, wait, we will discuss this also. Let me discuss next field now. Next field is identification field. Guys, identification field, flag field and fragmented field. These three field is used for fragmentation. So before discussing this field, you have to understand fragmentation. So what is fragmentation? Who will explain fragmentation?
If the maximum transfer unit, like it is set to, say for example, 1500 bytes by default. So what will happen is if there is a packet size which is more than that, the MTU, then it will fragment that particular packet and send it to other side.
Very good. Anything else, guys?
And apart from
large data into small.
Okay, that is also good.
When segment is converted into packets, that's called the fragmentation.
No. Anything else?
apart from that, basically identification, what it will do is since the packets are being sent, so it will do the work of labeling. And as the fragment, if the fragmentation bit is set, so say for example, if there is a 2000 byte packet or data, so it will be fragmented into two, say for example 500 and 1500. So
Okay.
in first, sir, it will in one of the packets which it is sending outwards first, it will send the header information with that, and in other it will send the remaining data, And between these two fragmentation also there is some identification which is responsible to identify that those both fragment belong to one single packet. This far I have read.
Okay. See, by the way, I must tell you that you should always find the way to avoid the fragmentation. You should find the way to avoid the fragmentation. That router should not perform fragmentation. Soon we are going to discuss fragmentation as well, if anyone don't know what is fragmentation. But I must tell you first, you should find the way to avoid the fragmentation, because IP is an connectionless protocol. It is an unreliable protocol. It cannot track the data. Yes or no? IP protocol does not have track for the fragment data. So router should avoid fragmentation. Now question is, what is fragmentation? So in a very simple language, we can say fragmentation is a process of dividing large size of data into a smaller part of data. Now question is, why we divide large size of data into a smaller part of data? Because of MTU, guys. Let's say I have one router over here. This router have two interface, 0/0, and this one is 0/1. Done. MTU of this interface is, let's say, 1500 byte. That means router can forward traffic whose size can be up to 1500 only, right? If router will receive a data whose size is more than 1500 byte, it cannot forward it from this interface. So let's say router have received one data over here on this interface whose size is 2000 byte. Now router need to forward this data from this interface, but the MTU is 1500, so it cannot forward it from here. So in this scenario, actually router need to divide this data into a smaller part so that this router can forward it from here. Done. So this fragmentation is dividing large size of data into a smaller part of data. It is very clear to everyone, hope. And fragmentation is only needed when the packet size is more than MTU. Always keep in mind, you can write down somewhere this point, that fragmentation is only needed when the packet size is more than MTU size of a device. Then only device need to perform fragmentation. Okay, and we should always avoid it. Let's say I have a topology like this: R1, R2, R3. Here I have one computer, and here also I have one computer. Suppose MTU of this interface is, let me change. Yes, MTU of this interface is 1000. MTU of this interface is 1000. MTU of this interface is, let's say, 800. MTU of this interface is 500. Here MTU is 1000. Here also MTU is 1000. Now if this computer will send one data whose size is, let's say, 500 byte, tell me, any router will perform fragmentation? Will any router perform fragmentation?
No.
sir.
No, sir.
No, definitely no. Okay, if this computer is sending a data to this computer whose size is 800, which router will perform fragmentation?
R3.
R3? How?
No one will perform.
R3 will perform R3.
No one will perform. See, R1 will receive this data on this interface. After that, it will forward it from here. MTU is 1000 and the size of data is 800. It will forward. Router 2 will check the MTU of this interface is 800 and size of data is also 800. It can also forward. Now this interface, MTU is 500. It can receive the data whose size is 800, but it cannot forward it from here. So it can receive it and simply router 3 will forward it to computer. So here also no any router is going to perform fragmentation. Done?
One question, sir.
Yes.
Because when you were trying to explain the first, are you saying that when data is being forwarded, there is no fragmentation, but it's when it's trying to send out, that's when the fragmentation happens?
See, here in the same topology, if this computer will send data to this computer whose size is, let's say, 800 byte. So here router 3 will perform fragmentation.
Okay.
MTU means maximum transfer unit. If MTU of a device is 1000, that means it can receive a data whose size is more than 1000, but it cannot transfer. Getting my
Okay.
point?
Got you.
Got it?
Yeah, I got you now.
After that, let's say this computer is sending one data whose size is, let's say, 1000 byte. Right? Definitely router number 2 will perform fragmentation. But if you want that your router should not perform the fragmentation, you can set one bit, one flag, that is DF. In the header, in the flag, there is one flag called DF, means don't
Fragment. Don't fragment.
Do not fragment.
Yes. So
I
if
think
this computer will say no, don't fragment, then router 2 will simply drop the data.
so. It is when 0, 1. It means then do not fragment in flex.
If value is 1, not by default value is 0. This means router can perform fragmentation. By default DF bit is
0 reserved.
0. Yes. And if you will set this bit 1 to 1, then router cannot perform fragmentation. Getting my point? Now is it clear?
Yes, sir.
Okay. So see, let's say router need to perform fragmentation. Guys, give me one very simple answer. You have one page of a notebook. Not here, let me make it in Paint. Okay, this is a page of page, right? And you need to break this page in 4 parts. Let's say you have divided into 4 parts like this. Okay, this is a part of page. This is also a part of page. This is also a part of the page, and this is also a part of page. Now we have 4 pieces of a single page. Yes or no? If I will tell you to combine these all parts together, let's say there are some more parts as well. So you need what? Identification. You need identification that which part belongs to same page. Yes or no?
Yes, sir.
So that is identification. Whenever router divide traffic, the router put one identification there. Here I am giving one identification 1. Here also I am giving identification 1. Here also I am giving identification number 1. Here also I am giving identification number 1. That means these 4 pieces belongs to a same page. Yes or no?
Yes, sir.
In the same way, let's say router have divide one data. This is data whose size is, let's say, 200 byte. So router have divided into 2 parts. Let's say 100 byte and 100 byte. So how we will identify that both part belongs to a single data? For that we have router will put what? Identification number over here, and identification number will be same. That means both are part of same data. Receiver machine can rearrange it. Yes or no? Yes or no, brother? Like this is part of this space here, this is also part of this space, this is also part of this space, this is also part of this space. So this is the first field, that is identification field. Here it is.
How
Then
to identify that what is the sequence of the data?
here is offset. We will discuss about that also now. Fragmented offset. This is for sequencing. First understand the flag now. Identification is clear?
Yes.
Is identification is clear to everyone, guys? Please let me know.
Yes, sir.
Router will mark all the fragments with a unique number, and that is known as identification. Okay, identification helps to recognize the fragments who belongs to same data. We can say that also, yes or no? It helps to recognize the frame who belongs to the same data. If data is fragmented, then only the receiving machine will assemble that data, right? Let's say between source and destination there are thousands router, and your first router have performed the fragmentation. Doesn't matter, all router will forward fragment packet, only your receiving device will reassemble the data in actual format. Because let's say my scenario can be like this: router 1, router 2, router 3, and router 4. Here we have destination, here we have source. This PC have sent one data, this router perform fragmentation, it have sent segment number 1 via router 2 and segment 2 via router number 3. So router 4 will receive segment 1 via router 2, segment 2 via router number 3. When this machine will receive, this machine will assemble the data in actual format. Okay, now we have flag. Flag field is also important inside the IP header. We have 3 flag. Let me discuss one by one. First flag is reserve. It will be always 0. Maybe in future we will use this flag, reserve. Second flag is by default it is 0 and it is DF bits. DF means don't fragments, and by default it is 0. If it is set to 1, then router will not perform fragmentation. And the third flag is also by default 0, and that is MF. MF bits. MF bits means more fragment. Okay. Okay, guys. See, in the flag we have 3 bits. First bit is reserve. Second bit is DF. DF stands for don't fragment. If this bit is on, then router will not perform fragmentation. If this bit is 0, then router can perform the fragmentation. And more fragmentation field is, it can be 0, it can be 1. If this field is 0, that means it is an last fragment packet. Last fragment packet. And if this bit is 1, that means more fragment packet is coming. More fragment packet is coming. Okay. MF. MF is more fragment. It is used to indicate the receiving machine that more fragment are coming or not. Coming or not. If it is 0, that means more fragment is not coming. This one is the last fragmented data. If this bit is 1, that means more fragment is coming. Done. By default it is 0. Okay. So hope it is clear that if this bit is MF bit is 1, that means this is not the last data. Not last. And if this bit is 0, that means it is an last data. Okay. After that we have next field, that is flag is clear, fragmented offset 13 bits, and this is used for sequencing. This is used for sequencing.
Sir,
Yes.
sir, why TCP protocol do not use fragmentation?
Where are you, brother? We are discussing IP header.
No, we are using the fragmentation in IP protocol.
We are using segmentation there. Suppose a traffic is generating at layer 3.
Okay.
Traffic using is coming from the UDP. Brother, at transport layer also we have what? Segmentation, dividing a large size of data into a smaller size of data. But that will be performed by TCP at transport layer. Let's say network layer is generating a data whose size is 2000 byte, and by default MTU is what?
1500 byte.
Yes.
Yes.
So router need to perform what? Fragmentation. Yes, Jayaprakash.
Yes, sir.
Okay. After that, fragment offset. So it is used for the data sequencing. Let's say let me copy my header again.
Sir, when whenever router needs to perform fragmentation, so it will also impact CPU utilization, or
Yes, so that's why first
okay.
I told you that you should find the way to avoid the
Yeah.
fragmentation, because
Oh.
definitely router will perform CPU utilization, right? Router does not have the track, right? So maybe router need to retransmit the entire data again.
Yes, sir.
These are the problem. Okay, but if we have concept, we are discussing the IP header, so we have to understand. Okay, let's say I have one router over here, router number 1. Router 2. Two routers, let's say we have, and we have one computer. Here also we have one computer. Okay, R1, R2, PC1 and PC2. Let's say PC1 is sending one data to PC2, and data is hello. Let's say hello, how are you? Hello, how are you? This is data which PC1 is sending to PC2, and router 1 have divided this data into some part, like hello, hello, is the first part. How, R and U. Router have divide this data into how many part? Oh my god. Hello, how are you and question mark. Let's say into 5 part. Router 1 have divide this data into, this is hello. Okay, after that third fragment, fourth fragment and fifth fragment. Done, guys. There will be there will be some size of data as well. Let's say size of, here size is, what we can say, any size of hello is, let me correct the spelling of hello as well. It is not looking. Okay, now what I am saying, let's say size of hello is 480. Anything we can consider. This is the size of hello. After that, size of how, this one is also 480, 480, 480, and let's say size of this is 40. Done. After that, router 1 is going to put identification number on all fragmented data. Done. Here value will be 1, 1, 1, 1 and 1. What do you mean by it? That means these all fragmented data belongs to a single data. Yes or no?
Yes, sir.
After that, there will be MF bit. So MF bit will be what? MF bit will be 1. Here, what will be the MF bit? 1. Here, 1 means more fragment is coming. MF bit 1. MF bit 1. But here, what will be the MF bit? This is the last
0.
data.
0.
0.
0.
Very good. This value will be 0 over here. After that, there will be sequencing. There will be the sequencing. So first sequence number will be 0. After that, the size of data 480. Then 960. 1440. This will be the sequencing. And here what value you will get, brother? Can anyone calculate? This is the sequencing. You can add the 40.
1480.
1480. This will be the sequencing. Means this is first fragment. This one is second fragment, third fragment, fourth fragment, fifth fragment, like this. And after that, router 1 will send it to router number 2. all segment. First it will send first, second, third, fourth, fifth, right? And destination device only PC2 is going to assemble the data again. Is it clear?
Yes.
Is it clear, guys, to everyone?
Yes, sir.
So now next field is C. We had discussed the version.
One second, sir. Can we go back to that to what we just
Yeah.
left now? Yeah. Sorry about that.
Here,
Yes. Now on that your calculations, the zero. If I look at all those 4 8 4 8 4 8, I think 148
I'm adding the size of data
Mm-hmm.
so that receiver machine can arrange it in actual order.
Okay. Now if it's arranging in the actual order from the
Identification,
zero, one
there
second,
is
sir.
identification field also, right?
Mhm.
And the sequencing as well. This is sequencing.
Okay. Now on the sequence, one second, sir.
Yes.
On the sequence, we have the first one as 0, right? So I
Yes.
think the numbers were supposed to go like for, one after the other from the 480. So I think one of the 480 is missing. Is that how it's being calculated? I wanted to be sure.
Yeah, you can calculate, you can add. Maybe the value can be different. Okay, just I am explaining the logic. Okay,
Okay.
understand the logic. I am not sure about the calculation, brother.
Okay.
Okay.
Got you.
But it will
So-
start with 0, right?
Yes. This field is also clear. This field also okay. Identification is done. Flag and fragment. See, now I am just going to show you these things practically on, so that it will, make you more familiar with this technical term like identification or more fragment, not fragment, and the fragmented offset. Okay. So for that, just let me open my GNS3. One second. Yeah, sorry. Okay, I'm going to design same topology over here. R1, R2, R3, 4. This is PC1. PC2. Here we can change the symbol of this device as well. Let's say this is your PC and this is also your PC. Guys, you all have installed EVNG and GNS3 packet tracer in your computer or not?
No.
No, sir.
No, sir.
No. Okay, so I will take one session only for installation. Okay,
Okay.
so I will tell you the date if anyone have all software, so they can skip that class. Okay, now topology is visible.
Yeah.
See, just I am going to configure the IP address and any routing protocol for the reachability. You don't need to do anything with the IP configuration and the routing configuration. Okay. Here on PC, let me configure the IP. Let's say here I am using network 10.1.1.0/24. Here I am using network 20.1.1.0/24, and between router 1 and router 2, let's say I am using 12 network 12.1.1.0/24. Done. Config T. First of all, I am going to disable the routing from here. So say no IP routing. IP default gateway is 10.1.1. Let's say 10, and IP address over here is, sorry, interface F0/0. IP address is 10.1.1.1 255.255.255.0. Say no set. Done. I've configured the PC. Let me configure the router 1. Config T, interface F0/0. IP address is 10.1.1.10 255.255.255.0. No set. Exit interface F1/0. Say no set over here as well, and IP address is 12.1.1.1 255.255.255.0. I'm using any routing protocol router EAGRP10. Guys, don't worry about the configuration now. You will understand all configuration later. 10.1.1.0 and network 12.1.1.0. Done. Config T, interface F0/0, no set. Exit interface F1/0, no set, and IP address is 20.1.1.10 255.255.255.0. No set. Exit router EAGRP is number 10, I think, network 12.1.1.0 and network 20.1.1.0. Done. Configuration of router 2 is also done. Let me configure PC2. Config 2T, interface F0/0, no set, and IP address is 20.1.1.1 255.255.255.0. No set. Exit. No IP routing, and IP default gateway is 20.1.1.10. Done. Ping, let me check the connectivity. Ping 10.1.1.1. So yes, there is connectivity between PC1 and PC2. You can see PC1 is able to ping PC number 2. Ping 20.1.1.1 is the IP address of PC2. Done. Okay. Now I am going to capture the link between PC1 and router 1. Okay. Let me capture this link over here. Okay, if I will capture this link, okay, and from PC number 1 I am going to send some ICMP traffic. Ping 20.1.1.1. Success rate is 100%, and you can see the ICMP traffic. If you will open any ICMP traffic, let me open this one. here is IP header. Okay, in the IP header you can see version. First version is 0100, means IPv4. After that, header length size is 20 byte. So as I told you that it is multiplier with 32. You can see the value is 5, and in binary 0101. Okay, after that this field is differentiated service code point. How many
P.
bits are there? 6 bit, and last 2 bits are ECN. Yes or no? I'm talking about
Yeah,
this one.
ECN.
Yes, sir.
ECN.
Yes, sir.
Quality of
Part
service
of
bits.
quality of service.
Yes, here. Yes or no? Yes,
Yeah.
we had discussed soon. Yes or
sir.
no?
Yes,
After
sir.
that, total length is 100. Means what is the size of data?
80 bytes.
80 byte. Because total is 100 and the header length is 20. That means the size of my data is 80. Out of 80, ICMP header is 8 byte information. 8 byte information. So actual size of data is 72. 72 byte plus 8 byte ICMP header and 20 byte IP header. So total size is 100 byte. Yes. And by default, see the flag field inside the IP header flag. This bit will be always 0, reserve field, and don't fragment. DF is also 0 and more fragment is
0.
also 0. Right? Now, question is, see on router number 1, or sorry, PC number 1, what is the MTU of PC? So, IP interface F0/0. MTU is
1500.
1500 byte. 1500 byte, yes or no?
Yes.
Yes.
That means this PC can transfer up to 1500 byte data from this interface. But if I will send ping 20.1.1.1 and size is, let's say, 2000 byte. Will ping work? Yes, ping is work. Ping is success. Success rate is 100%. But this time,
Fragmentation bit will be set.
yes, you can see. Fragment packet. Means PC will perform what? Fragmentation. PC will perform fragmentation. And if I will tell to PC that do not perform the fragmentation and size is 200 byte, and I am going to say DF bit, I am going to set the DF bit. DF means
Don't
fragment.
fragment.
see, success ping is
Not available.
destination is unreachable. Why? Because
Packet
PC
is discarded.
definitely PC cannot perform now what?
Fragment.
Fragmentation. Yes or no?
Yes, sir. Yes, sir.
Yes.
Okay, and here again I am going to say I am going to remove this bit. So now you can see success rate is 100%. Means it is able to ping. Yes or no?
Yeah.
Now what we can do one more thing over here. On router number 1, okay, on this PC, what I am going to do, I am going to change the MTU. Interface F0/0. MTU is, let's say, 500. I have set MTU what?
500.
500.
500.
Or on router interface, I can set MTU what? 500 on R1. Let me stop the capturing over here. I am going to capture link between router 2 and router number 3. I am capturing this link. Okay, and now I am going to change the MTU of F1/0, because from this interface router will forward traffic. This is outgoing interface. Here I am going to say MTU what 500. We can configure MTU from 1500 to this value only. So we cannot set MTU 500 over here. We can set MTU from 1500 to 1530 only. So okay, leave it for default value. Okay, and what I am going to do from PC number 1, let me send ping 20.1.1.1 and size is 2000. Okay, I am able to ping, and if I will set DF bit, then I am not able to ping. If I cannot send the MTU, what I am going to do, I am going to set the size of data is 5000. Please mute yourself from where I am getting noise. Guys, don't disturb other. See, here is capturing, and I'm going to send the data. Done. Okay, let me stop the capturing. How many fragments are there? Okay, let me open first fragment packet. Which bit is on? More fragment. That means this one is not the last fragmented packet. And identification is 35. Yes or no? See, in second fragment packet also, identification is same or not? And more fragment is 1. Yes or no?
Yes.
In this packet also you can see identification is 35, more fragment is 1. That means more fragment packet is coming. Four, 5. Can anyone tell me how many fragmented packet router will send? 6. And here identification number is what? 36. That means router 1 have sent how many fragment packet? 1, 2, 3, 4, 5, 6. Why? Because the total size of data is 5000. And router can forward traffic at a time is 1500 byte. So here you can see the size of data is 1480. 1480 plus 1480 plus 1480 plus 1480, 1480, 1480, and after that 1480. This is the last fragment. This one is not last, sorry. Here is last fragment. Where it is? No, this one is 16. This should be the last, and here more fragment bit should be 0. Where is the last fragment packet? Actually, this is, in WireShark, we are not able to see the last fragment packet, but here should be a last fragment packet where this bit should be off. More fragment should be 0. Okay. Okay, guys.
Yes, sir.
And when we are sending this packet with df bit on, this time what error I am getting? Dot dot dot. Here you know, in real time you will get what error? You will get MMM like this. This should be the error. This error means this is error of ICMP. You know, ICMP error can be dot dot like this, or this, or it can be like, what is the next symbol? Successful symbol is, if ping is successful,
Exclamation.
then yes. I am not able to see the explanation on my keyboard. Where it is? Here it is. Like this. Okay. This means, it means what? Timeout. Timeout. This means
Not
destination
reachable.
unreachable. Yes, unreachable. This means fragmentation is required. Fragmentation is required, but don't fragment bit is on, and this means successful, as you all know. Done. Okay, guys. And now in IP header, what rest field are there? Time to live, TTL. TTL is 8 bits value, so range can be 0 to 255.
120, 255.
Yes, 255. What is TTL? Who will explain the TTL?
Router to router hop count.
So it is the limit under which the packet should reach the destination, otherwise the packet is going to drop.
What is the purpose of TTL field in IP header?
To avoid loop congestion.
Yes, to avoid loop, not congestion, to avoid loop. Let's say I have router 1 and router 2. Because of misconfiguration of routing, maybe loop can form over here between router 1 and router 2. This one is R1. This one is R2. Let's say there is one loop between router 1 and router 2. Router 1 is sending one packet to router 2, and same packet router 2 is sending to router 1. Again, same packet router 1 is sending to router 2, and router 2 is sending to router number 1. So for lifetime traffic will be moving between router 1 and router number 2. So that's why we have TTL in IP header. Whenever a packet cross router, TTL will decrement by 1. And once TTL value will become 0 on any router, that router will drop the traffic. This is the concept of TTL. After that, we have next field, that is protocol field. What is the use of protocol field over here? This field is very important field inside the IP header.
It
It
tells
is
about
used
your
to
upcoming protocol.
upcoming protocol.
Like you are going to use whether TCP or UDP, something like
Upper layer protocol.
upper layer protocol.
Yes. Means who have hand over the traffic to IP protocol. That will be the information here inside the protocol field. Let's say if EIGRP have hand over the packet to IP protocol, so there will be protocol number of EIGRP, that is 89. If TCP protocol have hand over the traffic to IP protocol, so there will be the protocol number of TCP. Okay. After that, checksum field are there, and then source IP. As you already know, source IP is and 32 bits address. After that, there will be the destination IP address, and there is one option field, and then data, actual data. Good, done, guys. This is your IP header. Now next header is Ethernet header, layer 2 header. If anyone have any question inside the IP header, you can ask. Feel free to ask me. Yes.
Sir, the first question is, as you told that if the data size is, for example, header, I am talking about the header is 22 bytes,
Okay.
and it not going to
Header
send.
size cannot be the 22 byte. By
Exactly.
the
Header
way.
size is not going to 22 byte. There is need to be add 2 bytes more, so that it can.
Okay.
That's called the padding you told. So
Yes.
what's its padding, sir? It's kind of a random data.
Option field.
So okay. So
Yes, that is random data. 010101 like
okay,
that.
that's the question, sir. So another question is segmentation, related to segmentation. So when we divide the data which we receive from the session layer, so when we
Okay.
divide this data into smaller parts, and
Okay.
the process of dividing into the smaller parts, the process is called the segmentation.
Yes.
And when we add the header, like a TCP header to each smaller units, then they are
Yes.
going to consider as a segment, right, sir?
Exactly.
So and my question is, another question is fragment. So when we divide the each packet into smaller units, then the process is called the fragmentation.
Yes.
And like sir, is it possible that for example, there is no TTL value, and the size of the
Okay.
size of the packet is 1500 bytes. So
Okay.
is it possible that is going to consume your whole your bandwidth, like with the passage of time, if the moving in your network, and so it is possible that with every hop count, the packet size is going to be an increase. This is possible.
No.
Okay, the packet size is going to be a same.
Packet size is going to be decreased. When TTL value will decrease, then packet size will decrease.
No, I'm saying if there is no TTL value.
Yes, then packet size will be same.
So okay.
Until the destination.
Or if there is no destination, means the packet is moving just around in your whole network, packet is moving. So
Yes.
so I read somewhere that the packet is going to consume your whole bandwidth, like every hop is the size of the packet is going to increase, somewhere
No,
mentioned.
how size will increase at every hop? Not
That's the
possible.
question, sir. I'm asking how the packet size is going to increase.
No. Maybe someone have written wrong information on the internet, or they have made the wrong video on YouTube.
So
That can be the possibility.
and one more question, sir. Just like, so each hop, the router is going to calculate the MSS value.
Maximum segment size.
Means which, for example,
All TCP based services, yes, will
because
perform.
every router have their own empty value, so it means that
Yes.
it have to calculate which every hop, sir.
Exactly. Yes.
Yes, sir.
Even you are requesting for a server from India to US. First, it is going to negotiate the list MTU between source and destination.
Okay, sir. Okay, sir. So,
Anything else?
so when we add the if we say talk about the packet at layer 3, so when we add the TCP header and IP header and plus data,
Okay.
then this is going to consider as a one packet, sir.
No, when you are adding the IP header, then it is considered as a packet.
So
Before that, it is a segment.
so we
One
not
segment.
at layer 3 we do not talk about the because it carry the information of the previous layer,
At each layer, we have two types of data. One is payload, and after that, data after adding the header.
Exactly, sir. When the data come from the transport layer at the layer 3, so it will it will take the TCP header, it carries the TCP header, है ना? At
Yes.
and at layer 3, I'm going to again add the IP header and plus data. So my question is, the whole thing is going to consider as a packet, or IP plus packet, IP header plus packet is going to consider as your
Actual payload plus header.
actual.
Let's say EIGRP have hand over one packet, one mass, one data to IP protocol. So EIGRP is a payload. EIGRP data is payload. Payload plus IP header is known as packet.
Okay, sir.
Right? Segment plus actual segment is what? Payload at network layer. So payload means for network layer, segment is actual information. EIGRP data is actual information. Getting my point, brother?
Yes, sir. Yes, sir.
Yes. Anything else?
Sir.
Yes, Nirav.
Sir, can we go back to that particular header? I just wanted to ask few questions regarding identification and
Okay.
fragmentation offset. So
Okay.
basically, identification is responsible for tagging each and every packet, correct?
Exactly.
And if the packet has been fragmented, so the fragment offset will take place, and that fragment offset is basically the identification of the fragment, correct?
Hello?
Hello? Yes, sir.
Yes. Now you are audible.
Yeah. So my question is, say for example, in this TCP header, we have got the identification field, correct? So
Yes.
identification field overall is the is providing a tagging or numbering to the packet
Exactly.
number. Okay. And if say
Exactly.
for example, if the packet is been fragmented into two parts, okay.
Okay.
So it will contain identification one and identification one, correct?
Yes.
But if that has been fragmented into two, so that fragment offset will be like what, like one or two, or it will be
0 plus data size.
zero.
It will start from 0. After that, data size plus data size plus data size, like that.
Okay.
In sequencing, like, brother, tell me, in TCP, how sequencing is work? I have sent one data. This is my actual data. Whose size is, let's say, 100 byte. So what will be the sequence number over here? 0.
Yes.
Zero,
Sequence
sir.
number is, let's say, 0. In next data, again size is what? 100. Next sequence number will be what?
100 plus 0.
100. Yes or no? And it will expect acknowledgement as well on 100. So like this only offset, fragment offset works. It will start from 0. That is also sequencing. It will start from 0. After that, it will add the data size.
Okay.
Done, brother. So let's say I have a data, one fragment data whose size is 100 byte, right? I have divided one data into multiple part, 100 byte plus 100 byte plus 100 byte, let's say into 3 part. Done, like this. So on each fragment, identification number will be same, maybe 1.
Yes. As it belongs to same packet, then it will be one.
1.
Yeah.
Here also it will be 1. Here also it will be 1. Sequence number will be what? Here sequence number will be 0. Here sequence number will be 100. Here sequence number will be 200. Like this. This is not sequence number, this is fragment offset. Yes, Nirav.
I'll go through some documentation for this. Still, uh,
What happened?
it is not teach fragment offset because like fragment offset basically it will do the
Fragment
same thing as
offset is
tagging.
sequencing.
Yeah, sequencing only, sequencing of fragments and
Yes, sequencing
identify.
of,
Yeah,
and logic of sequencing is exactly same like sequencing in TCP.
okay,
It is just starting from 0, after that adding the size of data.
okay. But then identification in packet won't be same as this, correct?
Identification will be same.
Yeah,
Here it will be 1.
yeah.
Identification, through identification field, what we did, we actually can understand that these all is a part of single data, yes or no? And through this sequence number, what we can do, we can assemble the data.
No.
That's it.
And sir, one more doubt. In packet capture, we can see that header length is 20 bytes, correct?
Yes.
So like yeah. So basically, it is header length is showing the multiplier as 5, correct, sir?
Yes.
So this is
32. Multiplier of 32.
yeah, this is the multiplier of 32 bits actually, correct? So
Yes.
how it decides about this 20 bytes, basically, like how it comes up with this value?
No, it will, see 20 byte multiply by 8. It is what? It is your
160.
bits
Okay.
divided by 32. 5.
Okay.
And binary of 5 is 0101.
So basically, it will check if
Again,
the
receiver machine will do what? Receiver machine will convert binary value in decimal. It will get 5 and it will simply multiply it by 32. It will
32.
get the
160.
length
Okay.
of header. It will came to know that, okay, total size is this one. Let me subtract 20 byte. So this is the size of actual data.
Okay.
Anything else? Yes, Roman, Mohan, Sunita.
Everything is fine, sir.
Okay. Then Ethernet header. Can anyone explain Ethernet header? How many field we have in Ethernet header?
Preamble, data
Okay.
frame delimiter, start frame delimiter,
Yes.
destination
SFD.
address,
Okay.
source address, length, and your
Length.
data,
No. Not length.
total length.
Total length. Inside the Ethernet header, is there any field, guys? Total length.
Type is
Type is there.
Type is there. Okay.
Yes, in Ethernet header, source MAC, destination MAC, and type. These 3 fields is important.
And header
Only.
checksum, sir. F.
Checksum. Yes. FCS. After that data. What is the use of preamble?
Sir, it's a random 1-0 number, sir.
What is the use? Why we have preamble field in Ethernet header? Okay, tell me the size of Ethernet header. What is the total size of Ethernet header?
Sir, if I consider like a source destination, then it's going to 66 bytes, 12 bytes, and
Okay.
2 bytes for your type,
Okay.
14 bytes.
12 plus 2, 14.
14. If I'm going to consider the checksum, then it's going to 18 bytes.
Yeah. Exactly. The size of Ethernet header is 18 byte. And if you will include the PDMSON and SFD, then total size will be
8
26 byte.
bytes or eight
Yes.
eight more bytes. 7 plus 1.
But generally
I
we
think.
say Ethernet header is an 18 byte information. 18 byte means source MAC, destination MAC, and type and checksum. Okay, tomorrow we will see the Ethernet header as well. It will take very less time. After that, we will start what? Cisco IOS. First, we will understand the IOS behavior of Cisco IOS. How Cisco IOS, boot, how devices are going to boot. What are the memory? How to break the password and how to save the configuration, how to take backup. But before that, we will discuss the application layer protocol. Some important application layer protocol like DHCP, DNS. We will perform practical of this protocol as well. Okay. Then we will move to IS. Then definitely we will start our main topic, that is routing. Okay.
Sir, I have one question related to flags, sir.
Yes.
Sir, I study somewhere that if the bit is 00, then it means reserved. If the bit is 01, it means do not fragment. 10, it means fragment, and when 11, then it is fragment completed.
Okay.
So but you mentioned that the something different. That's why I'm asking. That's confused. Which one is right? Like this kind. Like
I am also not sure with your explanation, brother. I know this what I explained to you.
okay, sir. Okay, sir.
I am also, not much experienced person, so who will give you always the right answer.
Okay, sir.
Okay,
Okay,
maybe
okay, sir. Okay, sir.
I am
Noted.
also working, and apart from it, teaching is my passion. So that's why just I started making video on YouTube, and from last 1 year I started teaching online as well. Okay. So sometimes, when you guys are asking question, I am also searching the answer on internet. But on the internet, what I saw, there are lots of wrong information as well. Okay, so what we said.
So even if we open different books, they mention you will going to learn something
Yeah,
new.
exactly, exactly. Even you if you will read, two book na, you will get two different concept.
Sir, when we will be having session for EVNG installation?
Okay, one day I will take session for EVNG. Don't worry.
Sir, what's the current configuration of your system, sir?
Yes.
What's
Sorry,
your
Rohit.
current configuration of your system? Like you're running the EVMG. That's why I'm asking, sir.
I am running EVNG.
Configuration like a 8 GB RAM.
No,
like
I have 32 GB RAM.
exactly, sir. So it is finds hard when you have a 8 GB RAM. It's hardly like you cannot build a big topology.
No, yes,
Understand?
exactly. I must tell you, if you are installing EVNG, guys, minimum 16 GB RAM is required. Minimum 16 GB RAM. That otherwise you should install GNS3 or Packet Tracer.
Sir, can you show just your system hardware?
Yeah, sure. See here. Is my screen visible, brother Nirav?
Yes, sir. Yes, 24 GB and i5 10 Gen.
24 GB RAM is there only.
So currently, sir, your this particular PC is having around 8 cores, I guess.
Yes.
Virtual cores. Okay.
And I have one more system. There I have installed 32 GB RAM. Actually, usually I am using EVNG in that system.
It's recommended to use 32 GB, I think. But
Yes.
है ना?
Exactly.
So, sir, are we going to install the GNS3 and all those stuff before we move on?
Yeah,
to...
GNS3 is also perfect.
Okay.
Sir, I installed GNS 3, but I also get GNS 3 web along with this, and it is asking me for a virtual machine as well.
No, not required. Okay, I will check. You know, on weekend you can give me the AnyDex, brother. I will check your installation
Can we
further
do this
manually.
weekend? Can we do this weekend?
Yes.
Okay.
This
Do we
weekend.
need to send you a private message or we are?
Yeah, private message.
Okay,
Yes,
all right.
private message.
All right. All right.
On Saturday is fine.
Yeah, Saturday is fine.
Okay, thank
Saturday
you.
is also fine. Okay, guys, then bye bye for today. We'll meet tomorrow. Let's see. Okay.
Okay, sir.
I send